Welcome to AMS Talks Value of Data. My name is Rick Bacon. I'm the Chief Executive of Aquametrology Systems. And today I'm joined by Bryan Galvin, an independent consultant with many years of experience in water treatment system management. Today we're going to be talking about the value of real-time THM data and how that can be used to monitor, manage intelligent water treatment systems based around aeration, which is being used for the removal of THMs. Bryan, thanks for joining us today.
Thank you, Rick. Happy to be here.
So for more than 12 years, you were managing the City of Gilbert's reservoirs and wells. And the city as a whole was producing, I think, 100 million gallons a day, serving about 200,000 people, and with reservoir capacity of about 45 million gallons. So you invested very early on in online THM monitoring. Can you give us a sense of what drove that decision?
Sure, Rick, I'd be glad to. We had about 14 reservoirs, and 2 of the reservoirs previously had THM stripping equipment installed by a vendor. And with the equipment running, we were still not meeting the MCL for THM. We were still at times far above the 80 parts per billion. We were reaching numbers up to 110 even in the hot summer months. Arizona, it gets very hot, and the reservoirs that I'm talking about were below grade with a metal roof and quite large 3 and 4 million gallon reservoirs. And what drove me to want to invest in the THM analyzer was we had to get it working. That was the #1 goal. We got to get in compliance and to make the water as best we possibly can. Without being able to actively or get something that was somewhat real time, it would have been very difficult. We didn't have in-house capabilities in the lab, so we would have to take a sample, send it out, wait a week. And with all the variables with the water quality changing, the temperatures changing, you would have been chasing your tail. So I was fortunate enough to get the approval to purchase this AMS THM 100, I think it's called, and that opened up a whole new world to me. I was able to now put some theories that I had into operation or into place and see what the real cause was and see what improvements we could make. I had a couple theories. #1 theory was we had inadequate airflow in the previously installed equipment. It was putting out about 750 cubic feet per minute at 4 inches of water in a quite large reservoir. It's 4 million gallon reservoir. The square footage of that metal roof was like 125,000. No, that's a cubic feet, but it's a large reservoir. And the other theory was we had 2 floating sprayers in the reservoir, and my other theory was, well, we're really not treating all the water possibly. We could be kind of treating the same water over and over again. So once we had the THM analyzer in place, I started equipping the reservoir with larger blowers, and I put these blowers on VFDs. I created a recirculation loop so we can move that water through the sprayers. All the water would be treated that way. And then also install the ventilation system on the end so it could produce more of a plug flow of air. So that we installed 2 10,000 CFM blowers and replaced the 750s with those. And then we also manifolded it across the reservoir, this rectangular reservoir, so we could blow all the way across the reservoir. Sorry about that. I should have muted that. So we could blow air across the entire length of or the width of the reservoir, and then have it flow to the vents that were also installed all the way across the reservoir. So we'd have like a plug flow of air. And these were all, like I said, were put on VFDs. The recirculation loop was created so we could move the water from the wet well that had no stripping equipment back to the reservoir and so forth, and keep that circulating and be able to adjust the speed and see what effect that had by getting the real-time data back. Very impressive results once we made those improvements. I think the problem with the lack of airflow was we were reaching the air saturation point. So we would just create an expensive water cycle of pumping this water into the air, vaporizing it, and once we hit the 100% relative humidity number or slightly above that, it just recondensed, fell back in the water, and we just recirculated from vapor to water to vapor and back to water again. We needed some way to push this air out and get some fresh dry air in so we could continue the process of volatilizing these or vaporizing these volatiles. And that seemed to be the biggest change, the biggest improvement with the changes. The recirculation loop also helped, and also the venting the air all the way across, so we had to plug airflow, made a big difference. And the beauty of having the AMS there and the history files was I only made one adjustment at a time, because I didn't want to be just turning knobs and not knowing what effect anything really had on it. And so I would increase the airflow and let that run like that for a couple of weeks. And then I would open up the exhaust vent, for instance, all the way across the reservoir and see what effect that had. And I would turn the recirculation pump on and maybe adjust the speed of the recirculation flow. And through having all these adjustable parameters now, and with the use of the AMS analyzer, it was so easy to really see what was happening. The history files, and having it on the cloud, you could look at it on the phone at home if you wanted to over the weekend, and just see how everything was going. So the main goal was to improve the water quality, and then having the real-time feedback was just instrumental. I mean, I was able to prove that the plug flow, or opening the ventilation itself, made about the 10 to 11 part per billion drop in the middle of summer, and the airflow increase was, I was able to achieve 55–60% removal in these two reservoirs, versus before with the smaller blowers, no recirculation loop and just one vent, and not vent all the way across the reservoir, we were actually losing ground in the summertime. So water would be coming in at, for example, in the mid 80s in the hottest months of the summer, July, August, and they would still increase from the mid 80s to the mid 90s with the equipment running. So we not only decreased it, we'll say the high numbers to 40–50% less, but we didn't gain. So we were actually gaining. So in effect, we were moving more THMs that way, I believe.
Fascinating. I know that you captured a lot of the data. I think it'd be really interesting if you could share that, because it shows this progression of your work from when you sort of started and where the data was being produced, to then how you were able to use that data in a sort of interactive, ongoing way to move things forward.
Sure. I have the month of September's data, and September in Arizona was extremely hot. It was record high. We broke records. We hit records of 113, 114, and 115 that month. So I'll bring up the first reservoir that I worked on. Can you see that?
Yeah, very clearly.
Okay. So up towards the top numbers are data plots for the backfill water coming to this reservoir. And they're up there between 80 and 90 generally parts per trillion, or per billion, excuse me. And then the numbers below, you'll see 4 numbers down towards the bottom here. These 4 numbers are the water in the reservoir. So we're taking 4 water samples for every time we backfill. And the backfill samples were always taken during backfill time. So they're always midnight and 4 in the morning. And then we would take 4 more samples during the day. And usually when we backfilled the water, the first plot would show the water is a little higher than the next 3 plots. And that's because the THM equipment was actually knocking it down even farther and farther. And then we would backfill and basically start the same process over. So before we put this THM stripping equipment enhancements in, we had the AMS monitor in previous to any improvements. And these numbers would start up here and they would actually go up in the wet well. They wouldn't come down at all. They'd go up slightly by 10 to 20% higher. And I joked a little bit about we actually have THM producing equipment, and that was just kind of a joke. But I shut it off to see what would happen without the equipment. And with the equipment running, existing equipment before enhancements, we were gaining, like I said, 10 to 20%. But when I shut it off completely, we were going from these mid 80s to 110, 115, I think even 120. So, I mean, it's just within a couple of days. So I immediately turned the equipment back on and brought it back down to the 90s in the summer months, and then started making these enhancements. And this is the improvement we was able to obtain. I mean, we just knocked the heck out of it. This is showing about I think it was about a 55% removal efficiency over this entire month for, I mean, an average for the month of September, and the average high temperature was over 140 degrees. So we kind of threw a lot at this reservoir because we wanted to see what worked, what didn't, what was necessary. We didn't want to go spend a ton of money on all these reservoirs and overkill things that, you know. So the interest in saving money, well, we saved money in a couple of ways. Almost all this equipment we installed in-house, so the cost was very, very reasonable. And then we determined what worked, and then we moved it on to the next reservoir. I'll pull that slide up too.
It's probably worth pointing out for your viewers that our viewers that the regulatory limit is, you're very close to the regulatory limit for those contaminants.
Correct.
And the vendor systems that you were using generally claim sort of a 40–50% reduction, right? In
right.
The aeration system, removing these THMs down to those levels of around 40. So that also supports the sort of the general context, right?
Yeah, that's true. And the big flaw, I think, in the originally installed equipment, obviously, was the lack of airflow. Like I said, I believe we were reaching we were saturating the air to the point where it could not absorb any more volatiles, and they were just recondensing and dropping back in the water, and then pumping it up and repeating the same process over and over again. So yeah, you're correct. The equipment that's actually spraying the water is doing a fine job. I mean, we are using the same equipment. We didn't modify that at all in either one of these first two reservoirs. So only thing we did was enhance the airflow. Enhance it. We took it from less than 1,000 CFM. Well, there's two blowers. Each one was 750 to 1,000. So say rounded up, say to 2,000 CFM to about 20,000 CFM. And another thing that was learned, well, at least from my standpoint, was it's very cheap to move the air. It's expensive to move the water. So it sounds like, wow, he really overkilled that by putting 20,000 CFM of air on this reservoir. And that is an overkill. I intended to be an overkill because I put them on VFDs, and you can slow those VFDs down to run at much lower volumes. I installed anemometers in the ventilation system so I could measure the velocity and convert that to CFMs and measure the amount of air. And they start putting charts together to see how many CFMs of air you needed per cubic foot of reservoir in this temperature to be able to get the reductions I needed. So we took that data to the next reservoir and more appropriately sized things, and the improvements were even a little bit better. We took what we learned and installed them on this reservoir, which was slightly smaller. And this is a 2 million gallon reservoir, and we got close to 60% removal here. And then just one more slide I'd like to buzz through if we have time.
Yeah, sure. No, I think this is really showing the value of data, which is the purpose.
Oh, it is. I mean, I don't work for AMS or anything like that, but this equipment was extremely reliable, and I don't know how we could have obtained results like this without it. We were completely flying blind. We had a dumb system with no automation, no adjustments other than on-off, and was able to put in a beautiful system with variable controls for the airflow, for the recirculation amount. And even on this next slide, we even took it one step farther. We installed our own equipment. You know, once we determined the airflow made such a big difference, we thought, well, the longer the water is in the air, the better off we are, maybe even still. So we installed Beat brand nozzles up on the roof of this reservoir. And that's, if the reservoir is half full, it'd be about a 15-foot drop from where the water is being sprayed till it hit the water surface. And we was able, this was the worst reservoir for THM levels by far. We were hitting numbers in the 130s. And we was able to drop that down. I actually hit a number I think it was in July of about 18. So I thought, well, we can slow this down a little bit. And we still, on this slide here represents close to 80% THM removal. And what we're doing there is we use one of the 5 booster pumps that goes to the system and made it dual purpose. We made it so you could valve it to run the water from the reservoir through these spray nozzles and back again. That way we're recycling the water and circulating the water and using the existing equipment is the sprayer, and then the blowers are blowing the air through that water as it drops, and we was able to obtain about 80% removal. It's just so couldn't be any happier. I mean, could never have gotten here without being able to measure near real time. I mean, we're getting 6 tests a day roughly. So let me share this. Their stop this year.
It's a fascinating insight into the complexity of managing water quality. You clearly had some very significant challenges, and it's amazing the results you were able to capture with that. And just by having informed design or redesign decisions that brought about those results. So it's been great working with you, but it's been great getting that detailed insight into how you manage all of those complexities and the variables that you were playing with. And I'm sure a lot of people will find that fascinating. Get myself sorted. So Bryan, we've talked about the benefits that you've generated from this online monitoring. Where do you see online THM monitoring going, given your experience?
Well, based on what worked for me, and I think it would be worth looking into for other people, is the automation that you gain and the intelligence. I mean, now you can save money. You can have stuff triggered on and off, speeds adjusted, and just get exactly what you want for THM removal. You don't have to worry about overkilling or underkilling. I mean, the power to run the air systems is very cheap, very reasonable. And the advantage of the automation system, like using the AMS, is it becomes an intelligent system. It takes away a lot of errors. People don't get involved that may forget to turn something on or something off, or adjust it, forget to adjust it this day or that day. With the automation system, it's automatic. If THM levels are at a set point that you like, then you can use that outputs of the machine to the PLC to say, okay, I can slow the blower down. I don't need to recirculate. So I guess trying to sum it up, you can get energy savings by automation. You can get optimum THM removal, better accountability, improved customer confidence, I would say, because you don't have to send them any overrances or any exceedances that you may have had, and you just get tighter controls. So my opinion is automation is the future.
Were you using the sort of predictive analytics capability of the analyzer at all? I mean, obviously this was measurements of water within the tank at given times. Have you thought about that in terms of way forward?
The predictive software seemed like it was very accurate. I didn't get as much time on it as I wanted to. And the reason I can say that is we had 2 reservoirs that were in line with each other. And the predictive software from the first reservoir matched pretty dang closely from what I could tell. I didn't put tables together and I didn't track it as good as I did some of the other data. It looked like it would be a very useful tool, maybe from the standpoint of cost. I installed several of these out there at several different reservoirs. With the predictive software, you may be able to cut back maybe on some of the equipment costs and use that feature more.
Great. Well, it's the advantage, you needed to control your tanks, but obviously the compliance point is the water quality when it gets to the consumer, right?
That was another point I was going to make, is that was one of my goals as well, is I want to know what the THM level is as close as I can to the consumer. And by installing this equipment out in these remote reservoirs, which were far away from the surface water treatment plants, where the problem kind of starts with the chlorine mixing with the organics, we may have good numbers there, but what were we having on the other end of town? So that was another goal for me to want to install them out there in the site. I mean, the predictive software, it may be very good, but I'm more of a numbers person. Tell me exactly what it is.
Right.
and they've been extremely accurate. The THM readouts match the lab and very consistent. So I'm one of those people that has to see to believe, and tested it many times and gained a lot of confidence.
So one of the concerns of people who adopt online monitoring, particularly in remote locations, is, okay, I've got this data out there. Firstly, can I rely on it? But can I rely on the machine? And it's not only about accuracy and precision, right? It's about availability.
Mm-hmm.
You've obviously been exposed to a lot of instrumentation during your career. How do you feel that companies cope with that? Because it's no good having a box that's not working and you don't know it's not working because it's 50 miles from home, right?
Yeah, that was a very good selling point for me, because I didn't want to have to train people and rely on people that are doing 15 other jobs to be able to maintain a piece of equipment. So with the AMS system, it's monitored remotely 24/7, and I would get a call sometimes, hey, we need to check something out. There was a anomaly here or there, and I wouldn't even know it. They would know it before I would. So they have parameters set up where something exceeds that or is out of those tolerances. They must have like a SCADA control system or something like that notifies them, and then they'd call me and they'd come take care of it. So we had to do nothing, no maintenance, nothing. And the history that we can obtain from the cloud, it's just invaluable, because every adjustment I made on the THM stripping equipment, as far as airflow or speed or flow or any of that kind of stuff, or temperature changes, I could cross-reference that to the history of the files that were provided through the AMS cloud system.
Great. Well, I know that you're interested in sort of taking your knowledge of aeration and THM stripping out into the sort of the broader water industry. And I hope we have an opportunity to work together on that, because I think you bring a huge amount of knowledge and experience that other water utilities would benefit from immensely. This is a first chance to share some of that, but hopefully we'll have an opportunity to do some more of that going forward. So
absolutely.
Once again, thank you very much indeed for your time. It's been a great help.
Absolutely. Thank you, Rick.